Hello, this is Jimenez. In this video I will show you my IoT project. It is intended to demonstrate the embedding of software for a GPS module, the format for uploading observation data to a cloud server, and finally visualize and monitor the positioning data. First, I will show you the GPS receiver with embedded antenna of L1 frequency and CA code. This is the SR93 GPS shield for Arduino. It uses 3.3 volts power supply, has serial terminal to receive GPS data in a PC, or to write in a SD card. It has 5 pins, and the pin number 3 is the TX port, a serial data output. The output protocol is NMEA for datum WGS84 at a minimum default baud rate of 4800 bps. The rest of the pins are useful, but I'm not going to explain in this video. This is the Arduino 101, also called Genuino 101. It is a 5 volts end-to-end solution for development. It has an Intel Curie module, a 32-bit Intel Quark SE core, which is Pentium x86 compatible. The board comes with Bluetooth and motion sensors, like accelerometer, and gyro sensors. It has 20 general-purpose I/O pins, 1 serial UART port, 1 SPI, and 1 I2C port. Its array is compatible with the GPS shield. The way to connect the two boards is straightforward, as you can see in this video. This is the IDE available for free from Arduino to program the development board and embed the software. The GPS shield comes with a free software library in C language to use with the Arduino board. The file TinyGPS provides the NMEA parsing, the decoding of the GPS positioning. Also, there is one example file available to begin programming with the Arduino board. I customized the example file to obtain some available positioning data coming from the GPS sensor. After embedding the software, you can see positioning data using Arduino's serial monitor function, as shown in this video. Instead of using Arduino, I could use the ST development board. I selected the STM32F401 Nucleo because it is specially designed to copy the connectors of the Arduino. The way to connect the GPS shield with the ST boards is also straightforward as seen in this video. I customized the embedded program for the output from the GPS shield to write the positioning data in the SD memory. I collected the number of satellites in sight, HDOP, which is the horizontal dilution of precision, latitude, and longitude of my GPS receiver, day, time, and other information, as seen in the screen right now. Next, I will transform GPS measurement data to a JSON format to upload to a cloud server, not as structured data. I used Python as the programming language and the IDE version 3.8 for converting the GPS measurement from the CSV file, as seen in the screen, to a JSON file. As you can see in this video, the program for making the automatic conversion is small.